Let's do our second exercise. For this, we are asked to draw the projection of a point. Let's say it's point A, and its length has been given to us. We see that the level is 4, interval is 8, and distance is 6. And we are supposed to do the drawing on a pair of Monge. First of all, we can prepare this for our exercise. We need an A4 graph paper. It's just normal squared paper, not a millimetric paper. First, we need to draw these 3 squares with a set square, with a small set square or freehand. We can draw freehand. But this square here, the first one that we are going to draw, that includes 10 times 10 grids. We just need to count 10 squares on this direction, 10 squares on this direction, and we are going to draw a square, and we are going to name it with capital H. It's our horizontal projection plane, and then we are going to put these 2 letters, X and Y, to this line here. And then we are going to draw our second square, again, 10 plus 10 grids. And we are going to name it with capital V. And our last square, 10 plus 10 grid. And we are going to name it with capital P. First, let's draw this on our A4 graph paper. And then we are going to do the exercise. Let's look at the actual position of point A. Here we see it on the space, and there is our horizontal projection plane symbolized with capital H, frontal or vertical projection plane symbolized with capital V, and our profile projection plane symbolized with capital P. And we know that level, interval, and distance, they are the perpendicular length to these projection planes. The distance, the length between the actual point and its perpendicular length with horizontal projection plane, that's what we call level. Its perpendicular length with vertical projection plane, that's what we call interval. And the last one we call distance, that is the perpendicular length between actual point and profile projection plane. So when we cast our ray and it hits the point A and it casts a shadow, a mark on the horizontal projection plane, we get A prime. That's the first projection of point A. We name it as A prime. And this perpendicular length here is 4 squares. 4 squares. When I say square, I mean the square of our graph paper. And here we change the position of our ray. We cast the ray from this direction towards here. And when it hits the actual point, it will cast this shadow, this mark on the vertical projection plane, which we can call A double prime. It means it's the second projection of point A, and this perpendicular length here is 8 squares. 8 squares. And last, we cast our ray from this direction towards here. It hits our point and it marks a point on the profile projection plane, which we can call, we can name A triple prime. It means the third projection of point A. So by using these 3 rays, we created 3 projections of actual point. And now we are going to, and this perpendicular distance here, length here, that is what we call distance, right? Now we can create the Monge, a pair of Monge, but before that, we need to realize that this level here, this 4 square perpendicular length, this length here, it is equal to the perpendicular length between a double prime and xy axis, and also it is equal to a triple prime and this axis here, the perpendicular length between a triple prime and this axis, this line here. It is same with other lengths. This 8 square length, perpendicular length between the point A and a double prime is equal to the distance between A prime and xy line. It's also 8 square. And here we see the same length between a triple prime and this vertical line here. The distance, the perpendicular length between A and a triple prime, 6 squares, it is equal to the perpendicular length between a double prime and this vertical line here, and a prime with this horizontal line here. They are both 6 squares. So now we can start to open the system to create the pair of Monge. First, we need to rotate horizontal projection plane along this line for 90 degrees. And when we rotate it, as you can see, A prime is being rotated with the horizontal projection plane. And then we need to rotate the profile projection plane along this vertical axis, along this vertical line here for 90 degrees. And again, with the plane, the A triple prime is being rotated. So now we have the system opened. We just need to look at the system from front, like this. And this is the pair of Monge. This is what we need to draw for our second exercise. And it is very important to understand these relations. Okay, now we can do the drawing. First, let's start with looking at the system, this three-dimensional system, from different points of view. Let's look the system from above. Imagine that we are here and we are looking down, and try to understand what we are seeing in front of us. First, we see the horizontal projection plane, right? This is the horizontal projection plane, and we see it here. Imagine that you are looking from above, and right in front of you, there is this horizontal projection plane. And just concentrate to this part of your drawing. Try not to see the rest of it. Just concentrate on the horizontal projection plane, because that is what is in front of you. And when you try to see the vertical projection plane, you cannot see it because you are looking from the above, and it is just a line here, this line. You see the plane as a line because you are looking from the above, and you will not be able to recognize the plane. You will just see its side, its edge here. And how about the profile projection plane? It is the same. You cannot see the actual plane. You will just recognize its upper edge here, this one here, and you will see it like this. So this is what you see if you look from the above, right? And you know that your point A is positioned here, and you will, in order to draw it on the pair of Monge, you need this length here, and we know that it is interval, right? It is interval and it is 8 squares. And as we talked earlier, it is equal. The actual length between point A and vertical projection plane here, as we see as a line, this length is equal to A prime and vertical projection plane. So this is what I need to do. I need to count 8 squares, right? I need to count 8 squares, and I know that my first projection, A prime, is somewhere on this line, right? And in order to locate the A prime, find its true location, I need another length. This length here, it is the distance, and I know that it is equal. The perpendicular length between A and A triple prime is equal to the perpendicular length between A prime and the profile projection plane. So I need to carry this length over my drawing. I need to count 6 squares starting from this image of the profile projection plane towards the left. I need to count them, and at their intersection, the intersection of interval 8 squares and the distance 6 squares, I can locate the exact position of A prime. This is where A prime is located. I can draw a cross like this, but please remember that we talked about this last week. There are different line weights, and each line weight has a meaning, and we need to use this type of line weight, the one in the middle, not too dark, not too gray, not too thick, not too thin, the one in the middle. And we are going to write A prime on our paper. And please, again, remember that when we are lettering, we need first create rows with this time thin and gray lines. We need to create these rows and write our letter or draw our letter according to the rules that we have discussed last week. So first I need to create this line and then this line and write my letter, draw my letter in a perpendicular, symmetrical, and proportional way. So I write this. Now I need to change my position and look at the system from front, from this direction. Now I'm here, I'm looking at the system from here, and this is what I see right in front of me. I see the vertical projection plane, it's right here, and I try to concentrate on this vertical projection plane. I try not to see the other ones for now. And here, this time, I cannot recognize the horizontal projection plane because of my position. I just see its front edge. It's here. I just see the horizontal projection plane as a line. I cannot recognize that it's an actual plane. I just see its frontal line, frontal edge, and it is same with the profile projection plane. I cannot recognize it. I just see it as a line here. So this is what I see if I look from the front. And here, to draw the projection of point A, I need this length, the perpendicular length between A and profile projection plane. And This is the distance that I have just used. And I don't need to count one more time because it is right on my drawing here. I have already counted, I have already found this length when I was drawing the horizontal projection plane. And it is right here. I have already did this. I just need to carry this distance, this length up to the vertical projection plane. This is what I need to do. I need to carry this line towards up, towards to V. But this time I need to use this gray and thin line because it's not an actual line. It's something that I need to make a direction just to understand what I'm doing. I'm doing it for myself. So anyone else, they don't need to see it. This is why I am using this thin and gray line here. And I just carry it upwards. In order to locate the exact position, I need another length. And it is this level here. And I know that it is 4 squares. I need to carry this length to here, up here, because I know that the perpendicular distance between the actual point A and horizontal projection plane, it is equal to the A double prime and the length, the perpendicular length between A double prime and this line here. So I just need to, along this direction that I just made, I need to count 4 squares. And this is where I get my second projection. I just make the cross to point out, to indicate the position of the projection, A double prime, and that's it, that's all. Now I need to create my row and write my letter A double prime next to this cross. And in the third step, the last step, I need to change my position for the last time. Now I'm looking to the system from here, from the left side, and right in front of me, I realize that there is a profile projection plane. And I cannot be able to see the rest of the drawing. I'm just concentrating on this part of the drawing. And if I try to see the horizontal projection plane, I cannot because of my position. I will just recognize its edge. It's the edge that is close to me, and I see it as a line. And it is same with the vertical projection plane. I cannot recognize it. I will just see its line, the edge here. And this is what I'm seeing. And in order to locate the exact position of A triple prime, I need 2 lengths. First, level here. But I don't need to count 4 squares one more time because I already did that. I just counted and positioned A double prime here. So this is what I need to do. I need to transfer this length towards here by using thin and gray lines. This line here. And I need another length, that is the interval. Again, this is already on my drawing. I don't need to count 8 squares one more time. It was here. It was in my first step when I was drawing this part here. I counted these squares and I used this length to locate A prime. I just need to carry this information, this length up here. I don't need to count one more time, measure the distance one more time. I just need to carry this distance up here. Because before I opened the system, these lines were all together. They were just one line. It was just one line, and I divided it. I cut it in half. So by using this gray and thin lines, again, I just need to transfer this length up here, use my compass to transfer this length up here, and create a direction, create a border here. If I don't have a compass, I can use my 45 times 45 set square. And I know that this length here is equal to this length here. So it will be easier for me to just use my square if I don't have a compass. So once I carry this length here, it's right there, because I have already carried the this level here. It's the intersection that I'm looking for. I will put my cross with the actual line, not the thin one, the middle thickness one. And this time I will write, by creating my row, I will write A triple prime here. And this is it. This is what we need to do to draw the system on the Epure of Monge.